Okay, so we're leaving sequences behind. We're just talking about series. So series is another way of saying sums. And it's arithmetic if it has what we call a constant difference. Now, we're not going to do the examples on to the right, so you can put some notes there, or if you want to go scratchy paper, that's up to you. So we're going to give you a rule for a sub n. If you remember last week, we talked about a rule for a sub n. What you do is you take a sub n and set it equal to your first term plus n minus 1 times the difference. Remember that? And so we were able to use that in order to generate any rule for an arithmetic sequence and then convert it to a sum. Well, here's the other piece that you want to know. Let's say you want to add up n number of terms. So that means the sum of the first n terms. And that S sub n is going to be equal to the number of terms that you're adding up times the first term plus the last term divided by dos muchachos. Not we're dividing by two boys, but we're dividing by two boys. Y muchachas. I have very good Spanish. What was I thinking? Okay, so instead of and I understand that you could take number one and add it up probably pretty quickly on a calculator, but just suppose that there were 100 terms. That would be much more complicated, wouldn't it? We can add this up very quickly. It says evaluate the related series of each sequence. So this is currently written as a sequence. The series would be it all added up together. And the way that we do that is we say the sum of the first, how many terms are there? There are 6. So the sum of the first 6 is equal to, what is n? 6 times, what's a sub 1? 13 plus, what's a sub 6? 23 divided by 2. 13 plus 23 is 36. 36 divided by 2, or 36 divided by 2 is 18. 18 times 6. And that is your result. See that? So I'm going to circle problems that you should do on your own, okay? So do 3. But we're going to move on. But so for homework, you're expected to do 3, okay? Now let's try 5. Instead of it written out, now it's written in what we would refer to as summation notation or sigma notation. So we still want to evaluate each arithmetic series. We know it's a series because it has this sigma attached to it. That means sum. So how many terms are there in this one? How do you know that there are 35? What if the bottom said 4? And you need to regenerate the number of terms that there are. If it started with 4, then you would have number 4, 5, 6, so you'd subtract off 1, 2, and 3, so you'd actually have 32 terms. So you got to be careful if it doesn't start with 1. Do all these start with 1? Yep, so lucky for you. So there are 35. So the sum of the first 35 terms is equal to, you told me n was 35, times, how do I generate the first term? You plug it in. 5k minus 2 is the rule. It's all set up for us. So the first term is 3 minus, or I'm sorry, plus, what is the a sub 35 term? 173, very good. Divided by dos. somebody perform that operation on their calculator? 3080? Are there any questions on how I did that? Okay, so I will expect you to do problems 7, 8, or I'm sorry, 7, 9, and 11 as well. I'm going to show you how to do ones that don't look exactly like that. We're going to go to the back side. Let's look at problem number 15. What's that? Yep, just number 3. Okay, so let's look at 15. What makes 15 more difficult? It looks like it keeps going. It does say that it stops. In fact, it says that we are looking for S sub 16. It doesn't tell you the 16th term. Very good. So now we got to figure out how will we find the 16th term. Let's set up our sum first. The sum of the first 16 is equal to 16 is my n times the first term, you guys are right, 20, plus the last term divided by 2. So I have to figure out what that last term is. Does anybody have an idea how I would find that last term? Very good. I'm going to use this rule. We're not going to do the even, so I can use space over here to write. A sub n is equal to a sub 1 plus n minus 1 times d. I know that it's arithmetic because it told me in the problem. It says arithmetic. Therefore, I can default to this rule. So a sub n is equal to, what's the first term? 20 plus n minus 1 times, what's the difference? 7. So a sub n, and you guys, honestly, if you want to plug in 16 at that point, you can. You can plug in 16 already right here and get the answer. I'm going to show you the rule first, okay? So a sub n is equal to, that would be 7n, and that would be a positive 20 and a negative 7, which gives me 13. So that would be kind of the formal way of writing the rule. Now, how would I figure out the 16th term? Plug it in. 7 times 16 plus 13, 125. Now, is that a problem I can deal with? Sure is. All I had to do is use a secondary formula. What do you get? Louder. 1,160. By the way, there's a link leader meeting tomorrow, Tuesday at 7:30 a.m. in E213. Okay, I sent you text. I want you to do 13 and 17. I told you to do 11. We're not going to do any evens. It says determine the number of terms n in each arithmetic series. So now which variable am I solving for? Now I'm solving for n. So if we look at this right here, it says we'll do 19 together. A sub 1 is 19, A sub n is 96, and S sub n is 690. Which formula would you like to use? Would you like to use A sub n formula or S sub n formula? Let's use S sub n. Namely, S sub n is equal to, do we know what n is? No. Do we know what S sub n is? Yeah, so I'm just going to write that. 690 equals n times, do we know A sub 1? Do we know what A sub n? Divided by? Well, that's not so bad. We can figure that out, can't we? Somebody 19 plus 96 divided by 2. What you get? 690 divided by 57.5, 12. So I found the number of terms, yes. That's all I need to do. So see, these don't have to be super difficult, do they? Okay, so just 21 and 23. What's that? Those are textbooks for algebra. We were short 100 this year. Well, when the state mandated that the 8th graders all cover algebra, this was 3 years ago, that increased the number of Algebra 1 books we needed, right? But our enrollment was decreasing, right? Well, now the 8th graders came in, and that's 288th graders. So all of a sudden, we were able to get by. It was weird when the state mandated that. We were able to get by without really buying any more Algebra 1 books because our enrollment decreased that quickly. But now 288th graders come in, and it's like, well, never really thought about that. We'll start in the calculus books on Wednesday. They're right there. Okay. So that's arithmetic. No, you don't have to do 25. We're going to do some geometric. Then I'm going to give you a little bit of time to work. Then we're going to do infinite geometric. Okay? So this is a fun day because we're going to actually learn how to add up an infinite number of things, which you'll use later on. It's super exciting. Okay? We start here. Series means sum. Geometric means constant ratio, meaning you multiply. So arithmetic was we add a constant difference each time, whereas geometric is we multiply by a constant ratio every time. Okay? It's a little bit new, but it's super exciting. So strap yourselves in and get ready. Okay? So rule for a sub n. A sub n in this situation is equal to your first term. This gets really complicated. Times r to the n minus 1. Where r is your constant ratio. Let's do an example. S sub n. I never remember this one. S sub n is equal to, I think it's the first term. Yep. First term times 1 minus r to the nth divided by 1 minus r. And no, those don't cancel. Being else will cut your finger off. You know, Larry, it's so neat you do say, though, let's see an example, because the later on you go in life, the less examples you do, you just talk in vague terms. And I find that even if you're, talking about history or social sciences, it's best to look at case studies. Talk about an actual situation that occurred, and people can connect then. So, Can you guys look at number 1? Can you tell me what the constant ratio is? Yeah. Now, I'm not going to, we don't have to write it. It doesn't say it. It just says find the related series, meaning add it up. But if you wanted to write a rule for this, it's quite simple. All you do is you say a sub n is equal to, what's the first term? 2, and then you multiply that by 6 to the n minus 1. Well, we're going to get to, yes, n is 4 in this situation for the sum, but I'm just saying that's the rule. That will generate any number of the sequence that you would like. Now let's actually evaluate what the series is. Let's add up these four terms. Could add up these four very quickly on your calculator, but let's use our formula because we could change that from 4 to 400 pretty quickly. So S sub 4 is equal to, what do I put first? 2 times 1 minus 6 to the fourth divided by 1 minus 6. Good question. Why 4? Because there's 4 terms. What's that, Larry? This one? We're using this one. Finding the sum. So what is 6 to the fourth power? 1,296. And then 1 minus 1,296 is negative 1,295. You divide that by negative 5 and multiply it by 2. Good. So that's the sum. And you could check it pretty quickly here. Question? What we learned last week, the formulas that you're going to use what I give you today. Last week was to get your guys' minds in the frame of thinking, okay, what are series and sequences? See, I don't have to talk about the recurring pattern. You guys understand that. And we talked about a lot of different types of sequences before. We're only going to focus on arithmetic and geometric. Okay, so I want you to do number 3 on your own. Nope. I've got 2 more examples. I'm going to set you guys to work for a while here. Let's go to number 9. Nope. Just number 3. Okay, let's look at number 9. Is number 9 a sequence or a series? A series. How do you know it's a series? Because it has a sum. So what we need to do is we need to be able to express this. We could write it all out, but all it's saying is find the sum of the series, evaluate it. So I'm going to look for S sub, how many terms am I adding up? 8. I start at 1, I go to 8. Sum of the first 8 is equal to, okay? Sum of the first 8 is equal to, I take a sub 1. How do I calculate a sub 1? I plug 1 in. What's 1 minus 1? 0. Negative 2 to the 0 times 2. So 2 is my first term. Do I need to know the second term? No. I simply go 1 minus, this is where you got to be careful, okay? What is my ratio? How do you know it's negative 2, Emma? Yeah, if you look, A times R to the n minus 1. See it? R is what's being taken to the power. So we got to use negative 2 like that to the what power? 8th power. Divided by 1 minus negative 2. See if you can evaluate that. Okay. If we do work this out, this is going to be 2 times. We're going to have 1. Is negative 2 to the 8th going to be positive or negative? It's going to be positive. It's going to be positive 256 divided by the bottom going to be positive or negative 3. So we end up with 2 times whatever negative 255 divided by 3 is. Now, if you type this into your calculator, 1 minus negative 2 to the 8th without the parentheses around the negative 2, I think it will give you 257. So that's something you could encounter. So just be careful when you plug it in. So can you have a negative result? Yeah, if you're multiplying by a negative 2 every time, you know you're going to get negative numbers eventually. And we add them up, you're going to come up with a pretty bad result. So there you can do 5, 7, and 11. Let's try one more example on the back side, and I'm going to let you guys work here for about 10 minutes. 17. Sequence or series? It is a series. How do you know, Larry? Because we are adding them up, right? We're adding them up. That's how we know it's a series. And it wants you to find the sum of the first 7 terms. So here's what I do. I say the sum of the first 7 is equal to what is n? Do we want n? It says, what does your formula say? We want the first term. What's the first term? 1 times 1 minus, that's your first term. This is geometric. Geometric says you take the first term, right? So a to the 1 is 1 minus, do you see what the ratio is? It's good. It's negative 5. Got to use a negative because it's alternating between positive and negative every time. So I take negative 5 to the 7th power divided by 1 minus negative 5. So what we have here is, what is negative 5 to the 7th? So we're going to have 78,126 then when we add 1 to it. And you divide by 6. Okay. Okay, so I don't want you to do any of the 20s, anything beyond here. You can focus on these parts. So I'm going to give you about 12 minutes right now to work on any of these problems. And then I quick want to talk about our infinite ones, which may seem more difficult, but they're actually easier. So go ahead and give this a shot. So if you go to the arithmetic page, number 23, you can see that you have a, I didn't do an example exactly like this one. See if you can kind of stretch your brain a little bit, which looks like you're doing. So it says you want to find n. Is that correct? So what we have here is we're going to use the formula S sub n. So 21 is equal to the number of terms, which we don't know, times the first term, which is negative 3, plus something over 2. So the a sub n, we don't know what the last term is because we don't know what n is. But we can write an expression. And your expression is a sub n is equal to your first term plus n minus 1 times your difference of 2, right? So whatever I get for a sub n is what I'm going to use. A sub n is equal to 2n minus 5. So that's the nth term, 2n minus 5. So that's the expression I will substitute. Now, what should I do with that n out front? Distribute through. Oh, yeah, we'll combine what's on the inside first. 21 is equal to n times 2n minus 8 divided by 2. Do the 2n and the 8 divide by 2? Yep, so I get 21 is equal to n times n minus 4. So 21 is equal to n squared minus 4n. How do I solve that? How many solutions do we have? 2. So you have 7 or you have negative 3. Let me ask you a question. Could you have negative 3 terms? Nope. You can have 7 terms. So 7 will be the correct result. Yeah. Yeah, I'm trying to think if you could have an arithmetic series where you would have 2 that would be the same. You could. You could. You could actually end up with 2 results. Yep. Not very common, but you could have that. Okay, please turn to infinite. Infinite. If you have an infinite geometric series, that means it goes on forever. So let me give you the example here. We've only got till 10:50. We'll see what we can get out of it. I'm sure it will be excellent. But the fact of the matter is that suppose, okay, I am standing right here, okay, and I want to walk to the door. And every time I walk half the distance, so I walk half. So my total distance is 1/2 right now. Now if I walk half again, I will add a fourth to that. 1/2 plus a fourth is 3/4. Now I'll add an eighth, so that's 7/8. Then I'll add a 16th and get 15/16. Then 31/32, 63/64. 127 over 128. What number are you approaching? I will technically never reach the door unless I do it an infinite number of times. And at an infinite number of times, I will finally reach the door. It will sum to 1. Sometimes you can add up things and they converge to a number. Sometimes they don't. Here's the deal. If r, the absolute value of r is less than 1, it converges. The absolute value of r is greater than or equal to 1, it diverges. Meaning it will go to either positive or negative infinity, which comes up in calculus 2, some interesting series. It is extremely valuable and interesting to study. It's awesome, but we won't get there. We'll look at just some basics. This has a ratio of 4. Will it converge or diverge? It'll diverge. And if you don't believe me, try looking at the first term. What's the first term? Negative 3. And we would add on to that. My ratio is 4, so you would multiply the previous one by 4 to get negative 12, negative 48, so on and so forth. Do you see that that's going to go to negative infinity? Yeah. So if you have a ratio that's bigger than 1, then it isn't going to work out. How about number 2? It will converge. 3, converge. 4, diverge. 5. It's what, not what you divide by, it's what you multiply by. What do I multiply by? R equals 1/3, so it converges. Get that idea? How about number 9? What's the ratio for number 9? -4. R is -4, so it diverges. How about 11? What's the ratio? 0.2 is equal to the ratio. So does it converge or diverge? Converges. If the absolute value is less than 1, it converges. Do you see that? Oh, we won't worry about signs. So, can I show you something really cool? You don't have to write it down. Just watch. Let's say you wanted to add up an infinite number of these geometric terms. Well, your first term is just a sub 1, right? Your second term, you take a sub 1 and multiply it by r. Your third term, you take a sub 1 and multiply it by r times r again will be a sub 1 times r squared. I always take the previous term and multiply it by r. Watch. See if you can tell me what I did. What did I do? Factored out an r. Are you okay with that? Do you see how if I took out an r that I reduce the exponent by 1? If you reduce infinity by 1, what do you get? Still have infinity, don't you? This is the part you have to understand. Try to grasp your brain around this. The sum is equal to this guy right here, right? Isn't this what I have right here? Is that not the same as that? So I can now make this substitution. Sum is equal to a sub 1 plus r times the sum. I just put the s right there, right? What are we trying to solve for? Which variable? The sum. So I will get the s's both on one side. Do you remember from your pre-calculus how you solve that? Take out an s, we get 1 minus r. So if you want to know the sum of an infinite geometric series, take your first term and divide it by 1 minus the ratio, and you got it. Is that cool? It's awesome. Let's try it. Oh, but we've got a minute. I'm going to write it down. Sum equals a sub 1 divided by 1 minus r. And I will do the most basic example for you. Are you ready? Number 16. It says a sub 1 equals 1. R equals 1/2. Sum is equal to, what's the first term? 1 divided by 1 minus 1/2. 1 over 1/2 is 2. Do 13 and 15. 13 and 15. You have your homework. Work on it. Be ready to go tomorrow. We'll go over the answers. Back part, don't worry about it. What's that? Yeah, if you want to do more for fun, that would be great. You could do that. Just realize some of them may converge or diverge, but pretty cool how we just added up an infinite number of things, wasn't it? Happened just like that. Boom. Very quickly. Boom!